I hope this email finds you well. Thank you for considering me as a speaker for the upcoming digital marketing workshop. I appreciate the invitation and your thoughtfulness. The workshop sounds like an amazing event, and I would have loved to participate. However, I regret to inform you that I will be overseas on a business trip during the workshop. It is unfortunate that the timing does not work out. Although I cannot attend as a speaker this time, I remain hopeful for future opportunities where our schedules might coincide. I hope the workshop goes well. Setting out to find some wood for the campfire, Sarah moved through the forest. Just then, she noticed an approaching danger, a large, threatening bear. Panic spread through her body. Frozen and unable to shout, she watched in horror. Her heart beat louder with each step the bear took. But then, as if by a miracle, the bear paused, looked around, and, uninterested, turned away, retreating into the shadows of the woods. When the bear had disappeared, completely out of her sight, her knees nearly gave way. Sarah could finally let out the breath she had been holding. A wave of immense relief washed over her. There are few universals in this world, but among them are our love for our children and our love of music. When we hold a baby in our arms, comforting her with song, we're channeling the emotional power of music. We do so instinctively, just as our ancestors did. Music can be a powerful parental ally during the challenging child-rearing years. To successfully prepare our children for life in the 21st century, we will need to nurture qualities such as curiosity, imagination, empathy, creative entrepreneurship, and most of all, resilience. Musical practice in early childhood develops all of the above and more. Research has shown that musical practice in early childhood is beneficial not only for mental acuity, but for social and emotional development as well. Music is not just a hobby, a pleasant pastime. It is an integral part of what makes us happy, healthy, and whole. Indeed, if we want to do one thing to help our children develop into emotionally, socially, intellectually, and creatively competent human beings, we should start the musical conversation. The earlier, the better. In 1890, William James described attention as the taking possession by the mind, in clear and vivid form, of one out of what seem several simultaneously possible objects or trains of thought. Attention is a choice we make to stay on one task, one line of thinking, one mental road, even as attractive off-ramp signal. When we fail to make that choice and allow ourselves to be frequently sidetracked, we end up in the confused, dazed, scatterbrained state that James said is the opposite of attention. Staying on one road got much harder when the internet arrived and moved much of our reading online. Every hyperlink is an off-ramp, calling us to abandon the choice we made moments earlier. Nicholas Carr, in his 2010 book, grieved his lost ability to stay on one path. Life on the internet changed how his brain sought out information, even when he was offline trying to read a book. It reduced his ability to focus and reflect because he now craved a constant stream of stimulation. Once I was a scuba diver in the sea of words. Now I zip along the surface like a guy on a jet ski. Technical book knowledge consists of formulated rules which are or may be deliberately learned. Practical knowledge, on the other hand, cannot be taught or learned, but only transmitted and acquired. It exists only in practice. When we talk about practical knowledge, we tend to use bodily metaphors. We say that somebody has a touch for doing some activity, an ability to hit the right piano key with just enough force and pace. We say that somebody has a feel for the game, an intuition for how events are going to unfold, and an awareness of when you should plow ahead with a problem and when you should put it aside before coming back to it. When the expert is using her practical knowledge, she isn't thinking more, she's thinking less. She has built up a repertoire of skills through habit and has thereby extended the number of tasks she can perform without conscious awareness. This sort of knowledge is built up through experience, and it is passed along through shared experience. The human desire to make pictures is deeply rooted. At least 64,000 years ago, Neanderthals used colored oxide and charcoal to make paintings of large wild animals, tracings of human hands, and abstract patterns on cave and rock walls. Today, people create images with a multitude of mediums, including photography. What drives this picture-making impulse? Some make pictures for commercial reasons. Others create informational systems or employ scientific imaging tools to visualize the unseen. Artists use images expressionistically to conceptualize and articulate who they are and how they view the world. However, the fundamental motive for making the vast majority of pictures is a desire to preserve, to document, and therefore honor specific people, events, and possessions of importance. Regardless of purpose, the making of images persists because words alone cannot always provide a satisfactory way to describe and express our relationship to the world. Pictures are an essential component of how humans observe, communicate, celebrate, comment, and most of all, remember. What and how we remember shapes our worldview, and pictures can provide a stimulus to jog one's memory. We naturally gravitate toward people whose views and beliefs are similar to our own, seeking what the 18th century moral philosopher Adam Smith called a certain harmony of minds. Spending time with people who share our opinions reinforces our group identity, strengthening trust, cooperation, equality, and productivity. Our shared reality grounds us not just in our common perceptions, but in similar feelings and worldviews. This helps to preserve our core values and beliefs about ourselves. It also provides us with meaning and a feeling of self-worth. And with each decision or interaction that confirms our tribe's common experience, we get rewarded with the hormonal happiness we crave. Our perception of ourselves is a mixture of our own unique characteristics and our sense of belonging to our in-groups. In fact, our personal identity is so closely interwoven with our social identity that our brains can't tell them apart. If I put you in a scanner and ask you to talk about yourself, and then about the groups to which you feel the closest affinity, it will activate the same neural networks in your brain. The above graph shows awareness and usage of smartphone applications featuring machine learning in 2017. In each of the 5 surveyed applications, the percentage of respondents demonstrating awareness was higher than that of respondents demonstrating usage. Predictive text had the highest percentages of respondents in both awareness and usage among the 5 applications. The percentage of respondents displaying awareness of voice search was more than 4 times that of respondents using it. Voice-to-text showed a higher percentage of the respondents reporting awareness of it than email classification, while this was not the case in their usage. The percentage of respondents showing usage of automated photo classification was less than half of the percentage of those showing awareness of it. Mary Douglas Leakey was born in 1913 in London, England, in a family of scholars and researchers. Her father, who was an artist, took her to see the stone tools being studied by French prehistorians. This sparked her interest in archaeology. When she was just 17 years old, she served as an illustrator at a dig in England. Shortly after marrying Louis Leakey, she left for East Africa with her husband. Together, they made important fossil discoveries. In 1948, Mary found a partial skull fossil of Proconsul africanus on Rusinga Island in Lake Victoria. In 1959, in Tanzania, she discovered the skull of an early hominin that her husband named Zinjanthropus boisei, which is now known as Paranthropus boisei. Even after her husband's death in 1972, Mary continued her work in Africa. Mary died in 1996 in Nairobi, Kenya. 2024 Be Active Community Challenge. The Be Active Community Challenge invites all of you. Let's get moving this fall. When? October 1st to October 31st. How it works. Keep track of the number of minutes you were active every day. Every kind of exercise counts. Jogging, dancing, football, etc. Tracking your progress. Log your active minutes daily on the Be Active app. Deadline for submitting your total time is November 1st, 10 a.m. Entry fees $10. 12 years and under are free. Rewards and recognition. The 3 participants who recorded the highest total time will win a prize. Winners will be announced online. Heritage Hotel Stay Information. Dear guests, please read the following to ensure your safety and comfort during your stay. Check-in and check-out. Room check-in is from 2 p.m. Room check-out is until 12 p.m. During the stay, used towels are changed every other day. Free Wi-Fi is available only in the lobby. 2 bottles of water are provided for free. Facilities. The gym and business center are open 24 hours. The parking lot is in front of the hotel. Sometime late in the next millennium, our descendants may head off to other star systems. They may use comets as stepping stones, some of which are only loosely bound to our sun because they reach almost halfway to the nearest star system, Alpha Centauri. Our remote descendants may eventually colonize much of our galaxy, just as the first living organisms on Earth once colonized Earth's young oceans. Interstellar migrations will depend on as yet unimagined technologies for driving ships, for maintaining sustainable environments, and for putting humans into hibernations lasting for centuries. Interstellar journeys will also depend on the existence of groups willing to risk long and dangerous voyages with little or no hope of returning. It would take spaceships traveling at 1% of the speed of light more than 400 years to reach the Alpha Centauri system. But if they spread out from there at a similar rate, they could settle star systems throughout the Milky Way within 100 million years, which is just a bit longer than the span of time since dinosaurs ruled our Earth. Notably, young animals of many species have a special status, a leeway period granted by older members of the group. This break from the hierarchy is called puppy license by the behaviorists who see it in dogs, but it's a feature of family dynamics in a range of species. Older animals will overlook or gently correct an inappropriate display of dominance as long as the offender is young enough not to know better. Puppy license also covers play. Older dogs seem to enjoy puppy playfulness and may encourage young dogs by wrestling more gently, barking more softly, and sometimes letting the puppies win. As soon as that young dog hits a certain point in adolescence, however, its puppy license expires. Behaviors that were lightheartedly tolerated just a few days before are now met with adult pushback. Although the dog is still young and may lack experience, it is challenged and treated like an adult. In the human world and in the dog world, as juveniles mature into wildhood and their puppy license are no longer valid, a tolerant world becomes irritated and intolerant. After we make some amount of scientific and technological progress, does further progress get easier or harder? Intuitively, it seems like it could go either way because there are two competing effects. On the one hand, we stand on the shoulders of giants. Previous discoveries can make future progress easier. On the other hand, we pick the low-hanging fruit. We make the easy discoveries first, so those that remain are more difficult. You can only invent the wheel once, and once you have, it's harder to find a similarly important invention. Though both of these effects are important, when we look at the data, it's the latter effect that predominates. Overall, past progress makes future progress harder. It's easy to see this qualitatively by looking at the history of innovation. Consider physics. In 1905, his miracle year, Albert Einstein revolutionized physics, describing the photoelectric effect, Brownian motion, the theory of special relativity, and his famous equation E equals mc squared. He was 26 at the time and did all this while working as a patent clerk. Compared to Einstein's day, progress in physics is now much harder to achieve. Behavior is, for the most part, a product of genes and brain neural pathways. Consider the elegant chemistry at work when living organisms move, think, behave, and act. Certainly, the environment is a factor here because it can influence how we act. An analogy would illustrate this adequately. Think of the environment as gasoline, and our body as the engine. Truly, the engine does not run without the gasoline, but all the intricate parts of the engine are the product of physical architecture, designed and assembled for a reactive purpose long before the gasoline is injected. Inject more gas, and the engine accelerates. Less, and it slows. The same is true for an organism. Behavior is a response to the environment. We have free will, but the ultimate characteristic of that response can only act with respect to the architecture of our genes and our brain. In other words, the environment can effectively accelerate or slow down a potential behavior, but the engine for that behavior is already built and functional. Therefore, the environment is but a catalyst. The social cognitive revolution at 1 year of age sets the stage for infants' second year of life, in which they begin to imitatively learn the use of all kinds of tools, artifacts, and symbols. For example, in a study by Meltzoff, 1988, 14-month-old children observed an adult bend at the waist and touch its head to a panel, thus turning on a light. They followed the suit. Infants engaged in this somewhat unusual and awkward behavior, even though it would have been easier and more natural for them simply to push the panel with their hand. One interpretation of this behavior is that infants understood that the adult had the goal of illuminating the light and then chose one means for doing so from among other possible means, and if they had the same goal, they could choose the same means. Similarly, Carpenter et al., 1998, found that 16-month-old infants will imitatively learn from a complex behavioral sequence only those behaviors that appear intentional, ignoring those that appear accidental. Young children do not just imitate the limb movements of other persons. They attempt to reproduce other persons' intended actions in the world. As an ideal of intellectual inquiry and a strategy for the advancement of knowledge, the scientific method is essentially a monument to the utility of error. Most of us gravitate toward trying to prove our beliefs to the extent that we bother investigating their validity at all. But scientists gravitate toward falsification. As a community, if not as individuals, they seek to disprove their beliefs. Thus, the defining feature of a hypothesis is that it has the potential to be proven wrong, which is why it must be both testable and tested. And the defining feature of a theory is that it hasn't been proven wrong yet. But the important part is that it can be. No matter how much evidence appears to confirm it, no matter how many experts endorse it, no matter how much popular support it enjoys. In fact, not only can any given theory be proven wrong, sooner or later it probably will be. And when it is, the occasion will mark the success of science, not its failure. This was the crucial insight of the scientific revolution, that the advancement of knowledge depends on current theories collapsing in the face of new insights and discoveries. It is important to remember that to achieve acceptance and use of new technology systems, the personal importance to the users has to be valued more highly than the degree of innovation. However, policies and political goals are often confused with the driver's personal goals. Societal goals and individual goals do not necessarily coincide. For example, the policy goal behind ISA, Intelligent Speed Adaptation, a system which warns the drivers when they exceed the speed limit and may even prevent them from doing so, could be to increase traffic safety or to increase speed limit compliance. These goals might not be relevant to some drivers, for example, due to their feeling that safety measures are redundant because of their own personal driving skills or because speeding is not seen as a real crime. Nevertheless, they might find that the system helps them to avoid speeding tickets, or they want to use the system simply because they have a general interest in innovative systems. From infancy, even before we learn to speak, we absorb how to infer people's emotions from their behaviors. As we grow older, however, this capacity can atrophy. We start to pay increasing attention to what people say rather than what they do, to the point where we can fail to notice non-linguistic clues. Spoken language is so information-rich that it lulls us into ignoring hints that someone might be upset and instead focus on their words when they say, "It's nothing, I feel fine." Some people, however, have a talent for detecting emotions, even when they're unspoken. We all know people like this, friends who seem to intuit when we're feeling down, even if we haven't said anything. Managers who sense when a kind word is needed to help us get over the hump at work. It's natural to assume these people are unusually observant or uncommonly sensitive. Sometimes they are, but years of research indicates this is a skill anyone can develop. We can learn to identify the nonverbal clues that indicate someone's true emotions and use these hints to understand what they are feeling. Some epistemic feelings let us know that we know. These include the feeling of knowing, the feeling of certainty, and the feeling of correctness. For example, you feel sure that 1666 is the answer to the question, when did the Great Fire of London occur? Feeling that you know, even that you are sure, is not unfailing. We can be mistaken in those feelings. Other epistemic feelings alert our attention to what we do not yet know. Curiosity, awe, and wonder fall into this category. As with the feelings of knowing, we can ask whether feelings of not yet knowing are necessarily right. It does seem that if you wonder at something, there is something that prompted you to wonder. This feeling alerts you to the fact that your current body of knowledge, the schemas, heuristics, and other information you use did not prepare you for the thing you wonder at. As such, wonder is a useful emotion because it points to gaps in what you thought you knew. Memory often plays tricks. According to Mladenov, we give unwarranted importance to memories that are the most vivid and hence most available for retrieval. Our memory makes it easy to remember the events that are unusual and striking, not the many events that are normal and dull. The self-serving bias works because, as Trivers observes, there are also many processes of memory that can be biased to produce welcome results. Memories are continually distorting in self-serving ways. A recent study argues that several forms of cognitive bias cause distortions in storing and retrieving memories. This, in turn, has a bearing on theories of agenda setting, priming, and framing, which argue that how people respond to the news is strongly influenced by what is most easily and readily accessible from their memories. But what if memories about news stories are faulty and distort, forget, or invent what was actually reported? In such cases, it may be the manipulation of memories in individual minds that primes, frames, and sets the agenda, not the original news stories. One way to catch a fly ball is to solve all the differential equations governing the ball's trajectory, as well as your own movements, and at the same time, reposition your body based on those solutions. Unfortunately, you don't have a differential equation solving device in your brain, so instead you solve a simpler problem: how to place the glove most effectively between the ball and your body. The cerebellum assumes that your head and the ball should appear in similar relative positions for each catch. So, if the ball is dropping too fast and your hand appears to be going too slowly, it will direct your hand to move more quickly to match the familiar relative position. These simple actions by the cerebellum to map sensory inputs onto muscle movements enable us to catch the ball without solving any differential equations. We are also able to use the cerebellum to anticipate what our actions would be even if we don't actually take them. Your cerebellum might tell you that you could catch the ball, but you're likely to crash into another player, so maybe you should not take this action. Philosophical interest in poetry has been dominated by the question of whether poetry can aid philosophical thought and promote philosophical inquiry. This focus reflects a tradition of philosophers like Pope and Rumi presenting their philosophical work in verse. In addition, poets like William Wordsworth and T.S. Eliot have been celebrated as poet-philosophers, with their work valued as the product of philosophy through poetry. However, arguments against poetry having a role to play in philosophical inquiry have tended to focus on poetry's negative relationship to truth, or as John Cody puts it, poetry's indifference to truth. Although we may accept works of poetry as having philosophical themes, this does not amount to doing philosophy through poetry. One such argument hinges on the non-paraphrasability of poetry and form-content unity. The thought goes, if poetry is to play a role in philosophy, then it needs to be paraphrasable. That is, its content must be separable from its form. The assumption is that paraphrase is a mark of understanding and indicates that some proposition has a fixed meaning and that only a proposition with a fixed meaning can be evaluated in terms of truth or falsity. Poetry resists paraphrase. To change the words is to change the poem. Vocal sounds produced by parrots, regardless of the fact that they may be audibly indistinguishable from spoken words, and regardless of the fact that someone or some group of people may take them to be words, are not words. They are not given a semantic dimension by physical similitude to spoken words, nor can the talk of a parrot be given a semantic dimension by being taken to be a set of linguistic acts. In like manner, whether etchings on a stone or shapes in the clouds, regardless of how physically similar they may be to written words or drawings or objects, and regardless of what they are taken to be by observers, are not words or pictures. They do not have the appropriate etiology, and they have no inherent semantic content or object. They are simply physical objects that resemble certain other things. For observers, they may call to mind the things they resemble. In this regard, they may function as natural signs by virtue of the physical resemblance, but they have no semantic content about which one could be right or wrong. If people take A to be a sign of B, by virtue of some non-semantic relation that holds, or is believed to hold, between A and B, A is a sign of B. But words, pictures, and images are not that way. They include a semantic content to be understood. One frosty morning, a rabbit was jumping about on a hill. There stood a snowman, which had been made by some children. He had a broom in his hand and a carrot nose. The rabbit saw the carrot and swallowed hard. "I will have a delicious breakfast," he thought, and jumped up, reaching out for the snowman's nose. But before the rabbit even touched him, something hit him hard. "Go away!" the snowman threatened him with his great broom. "Sorry, Mr. Snowman, I just," murmured the rabbit. "You wanted to eat my nose," he shouted. "I was so hungry and it looked so tasty," apologized the rabbit. The snowman thought for a moment. Here, I am bored by myself. I would like to go to the village where the children are. If you take me there, I'll give you my carrot," said the snowman. Excited by the offer, the rabbit told the snowman to wait and disappeared. He returned shortly, dragging a sled, and said to the snowman, "Let's go!" The sled ran smoothly over the snow. The snowman, with joy, waved his broom. After a while, they arrived in the middle of the village. "Here we are," said the rabbit. "Thank you. Here's the carrot," said the snowman, giving him his carrot. The rabbit hesitated for a moment. "Come on, take it. I have a feeling that I'll get a new one," urged the snowman. He finally accepted the carrot and leapt back into the woods. Not long after, the children gathered around the snowman. Noticing that he had no nose, they gave him a fresh carrot. From that time on, the snowman stood in the middle of the village with a broom in his hand and a marvelous new carrot nose.